go. Okay, let's go. Okay, so good morning, everybody, and welcome to the third session of the theoretical classes of data visualization. Today, I'll be covering the contents that is in week 4. So I'm going to jump over class 3, then I'll go back to class 3. But I think it's more important to go here to the visualizing tables, chapter 4a, okay? Hope you are doing well with your final projects. So you can develop the project in Python, Dash, or in Tableau, as I mentioned before. So don't forget that the project should be delivered until 9th of April. Okay, so not a long time to go. So you have like less than a month. So, but the idea is not to develop so complicated things. Okay, so don't forget the focus is on data visualization concepts and theory. Okay. So the idea is that you get the data set. So it can be any data set. For instance, you got from Kaggle or World Bank or IMF or Statistics Office, or from a previous work you have done before in this course. And then you write down, I would say, 3, 4, 5 questions. So you have this table, okay? You write 3, 4, 5 questions and you ask, what is the information you want to extract with the data visualization products you are going to develop, okay? That's the main objective. Don't forget about this. So don't spend too much time acquiring the data set because that will not be valued. So what is valued is just the visualization aspect, okay? So ask questions and then develop visualization idioms that match or answer those questions. That's the objective, okay? So in the end, in the report, you also put there the questions you use to motivate your work. So I understand, me and the professor of the practical classes understand why did you select those options for answering those questions, okay? So the idea is not to create 20 or 30 charts, complicated charts. The idea is to create a product that matches the questions you have identified as important to communicate your message. Okay? If you have any question, let me know. Okay? So, continuing with this class. Okay, so today I'm going to cover visualizing tables, which is chapter 7. Okay, so let's go. So these are the contents of that chapter. Please take a look at the book from Tamara Mulsner, which is the author of the reference book for this course. Okay, as I mentioned, this course uses that book, which is a very well-known reference book in data visualization field. So I think it's good to have some standardized knowledge on this area, so I don't come up here with my own vision of what is data visualization. Okay, that's not the objective. Okay, so even the language that is used in this course is pretty much the one that is described in that book. Okay, so I'd like you to use also these terms for describing your reports. Okay, so arranging tables basically is the contents of this chapter, is the way we are going to go from our data set, okay, we have a table, into your data visualization product, okay? So my point here is there are hundreds of different options, okay? But it's up to you to decide which ones are the best or which one is the best to answer the questions you have written in the beginning of your project for your data set, okay? This is an exercise which is very useful because it's like developing a software product in which you have a list of prerequisites, okay, which you identified. And then in the end, we are going to match your product with those prerequisites to see if it matches or not what you wanted to do with your product, okay? So this is an exercise which I think is very useful to see if what you are presenting makes sense, okay? Please don't deliver shards that are not connected or don't have an objective in your application, okay? So the objectives should be clearly identified, okay? So we are going to see how to express those values. How can we separate or align them? So regarding the axis orientation, this can be rectilinear, which is the most common option, or it can be parallel or radial, less common options. Okay, about the layout density, we can use a dense or a space filling layout density. Okay, if you have any question, please let me know. Okay, so okay, I will make this recording available in the Moodle like it was the previous class, so then you can consult this whenever you want. Okay. Okay, so first type of visualization idioms. Okay, so one very common use of one common way of representing our data is through scatter plots. I'm sure all of you have heard about scatter plots before. So we have scatter plots whenever we want to represent two quantitative attributes. Okay, please identify in your report what type of charts you are using. Is this a scatter plot? Let us know. Okay. What marks and channels are you using? Remember the previous class? Whenever we are using scatter plots, we are using as marks points. So points is the way we are going to represent the items of our table. Okay. As visual channel, this is also very important. Please use this language in your report. Visual channel, we are going to use vertical and horizontal spatial position in our X and Y axis, okay? And we can add more attributes as we are going to see later on, okay? So scatter plots are very useful for finding trends, outliers, understand the distribution, correlation, or even locating clusters, okay? We can represent hundreds of items in a scatter plot, okay? So please pay attention to this kind of description. Try to use them in your report, okay? Here we have an example of a scatter plot in which we are representing diamonds, okay? Who doesn't like diamonds? Comparing the price against the characters, okay? Carrots, sorry. So the carrots, the higher the value is, you can see that there is a good correlation between the carrots and the price. Okay, so we can see there is some kind of correlation here. We can also add a trend line if you want. If you have used Excel before, you know it's possible to add trend lines to the scatter plots. Okay. So we have here an example of another data set about Titanic. Okay, everybody knows Titanic, right? So we are representing in a scatter plot the age of the passengers against the fare they have paid. Okay, so immediately we can see if the points are not on the diagonal, means that there is no correlation, okay, which is the case in this case. So the age is not important on the price of the ticket for the Titanic, okay? So we can use this kind of representations, scatter plots, figure out if there is a correlation or not between the variables, which might be very useful depending on our objectives, okay? We could add to that data set a third dimension, in this case, a qualitative attribute, okay? Here we are representing that qualitative attribute using 3 dimensions, okay? In which we had the category of the class, first, second, or third, in different spatial position also, okay? So as I mentioned before, we should avoid the use of 3D for our representations because we have the occlusion and distortion effects, okay? So we might be hiding some data depending on the perspective, okay? So don't use 3D unless it's required or unless you provide some kind of interactivity possibilities to the user. Otherwise, you might be hiding some data, okay? Which is always, or it's very frequent that it is the case, okay? Okay, here we can find an alternative option for representing that attribute, which is to encode the third attribute, which is the class, encoding using the visual channel color, okay? So we could represent class with different colors, and this is much more truthful to our data set because we don't have the perspective problem or the occlusion effects, okay? Okay, we can complicate our scatter plots, adding more and more dimensions, okay? Which is possible. For instance, this represents wines, okay? Each data point or each item represents a specific wine, which is characterized according to the attributes that are defined here, okay? Level of sugar, alcohol content, acidity, etc. Okay? So as you can see, this is a mess, right? Because you cannot distinguish almost anything if we start representing hundreds of items with multiple dimensions. It's possible, of course, but it's up to you as a visualization designer to judge if this is what you want to give to people, okay? So maybe it doesn't make a lot of sense to show so many dimensions. Maybe if this is an interactive product, you could give the user the possibility of selecting the dimensions he or she wants to display, okay? So you can add filters, which you are also going to use probably in your final project. Okay, filters are good because it allows the user to select what dimensions he or she wants to see, and maybe you could also add, because this is a 3D perspective, maybe you could also add the possibility of changing the perspective of the application, okay, of the charts. Okay, so we have here 6 dimensions for this scatter plot. Of course, your table needs to be ready to plot these dimensions using quantities, okay? Or qualities, for instance, you have different shapes. Shapes can be, in this case, qualitative attributes, okay? Okay, more examples. Another example of a multidimensional scatter plot. If you hear this concept bubble plot, it's the same, okay? Here it's representing characteristics of cars according to several attributes. They are described on the top right, as you can see. Okay, so this is pretty much the same type of example I've showed you before. Maybe you want to consider using a scatter plot for your project. Don't forget to identify this and describe this in your report. Okay, don't just create an application and throw there 3-5 charts. Okay, please describe them. Don't forget, if this is a data visualization course, I'm interested in your description of the visualization idioms that you have used. Okay, what marks and channels have you used? What kind of attributes are you encoding? How are you encoding them? Okay, so try to use this language, which is the one we are using for this course, and to communicate in a more scientific way. Okay. Okay, we can add trend lines, as I already mentioned before, to represent when we have, for instance, thousands of points, like the example we have on the left. We can use scatter plots, of course, but if we have too many points, maybe it would be useful to use some kind of different color, so it's not so overplot like the example we have on the right, where it becomes just a black area practically. We cannot distinguish the points. Maybe you can use some light colors for the points when you have too many points, and you can add a trend line. Okay, you have used Excel before, you know that you can add a trend line to your scatter plots. Okay, so be very accurate in the description. Don't call scatter plot the dot chart like we are going to see later on. Dot chart is not the scatter plot. Okay. So bar charts. Bar charts, they are very effective, as I'm already mentioned in the previous class. We use line marks. Okay, they express values aligned in the vertical position, and they separate a quantitative attribute using the horizontal position, or vice versa. I can have an inverted bar chart if I want. Okay. So, but it's really important that we understand when we are looking to the data set. Okay, these are quantitative attributes. This is an ordered attributes. This is the qualitative attributes. This is the geometry attribute, because this will have an impact on the visualization idioms we are going to use. Okay, so very important that we come up with possibilities that are the best, or we select the best possibility for the data set we have. Okay, so if you are using software like Tableau, okay, when you add the table or the data set to the software, the software immediately suggests you some possible visualization idioms or charts to represent that data set. Okay, but don't take the suggested options for granted as being the best. You are the smart guy in the room, okay? Not the computer, not the software. It's up to you to take the decision, okay? Sometimes the suggestions are not good, so, and in the end, you are the responsible for selecting the best possibility, okay? So, for bar charts, we have here two examples representing the same data. And maybe you should already try to figure out which one is the best, one on the left or the one on the right. Okay. So they represent the same data. Which one do you think is best to understand the data in the data set? Okay. So this is another option. Whenever you are working with bar charts, it's a good idea to order the values of the bars. Okay, so start by the smallest to the highest, or vice versa. Okay, for us it's much easier to read data like this than unaligned bars. Okay, We have a good example here in which we are showing graduation rates in US cities, so between 2 years, 1995 and 2005. And the author of this visualization, I think he or she did an excellent job by ordering the values of the cities from the highest to the lowest, and also separating the negative values from the positive values. So we can understand the differences between the positive and negative performance. And we can see, for instance, on the right also, which are the worst in this case, but they are also aligned from the highest to the lowest value, okay? So it's interesting to see here also the message that is being conveyed here, okay? You have a strong title, okay? And then we also have a small portion of text helping the reader to understand the contents of the visualization product, okay? So think about doing something like this for your charts, okay? Use text, use titles, so we come up with some powerful message, and you help also reading the application or reading the visualization product you are building, okay? So don't just throw charts there, waiting people to understand what you want to show, okay? It's up to you to decide what you want to show and what is the message you want to associate with, okay? So each chart you put there should be meaningful, okay? And the title used for describing it and also the text should be also adjusted to the message you want to show, okay? This kind of chart or this kind of visualization is pretty much oriented by the person who produced it, okay? You are not giving the reader the possibility of doing filtering or doing some selections. So it's author-based visualization, okay? It's not so user-based, but it's more author-based. So you are being told what to read, and you cannot actually do any changes here, okay? So you should also describe, we are going to talk about in one of the next classes about storytelling. You should also describe what kind of visualization are you delivering. Is it user-based, or is it open exploration, okay? Is it author-based, sorry, or is it open exploration? In this case, it's totally author-based, okay? You're not giving any opportunity to make queries or change any kind of results that you see, okay? Okay, when using bar charts, be very careful when you are reading or creating. For instance, this example here, it's a bar chart. It's correctly produced, but you need to be careful when reading the y-axis because it's not starting in 0, okay? So this, whenever you see these kind of situations, maybe you are being victim of manipulation because the person who did this, maybe he or she wanted to create a more impactful visualization. If this started in 0, these changes or these differences will not be so meaningful, okay? So if you want to show a big impact, maybe you will not start in 0. This is correct. This is not a lie because the y-axis is correctly identified, okay? But I've seen these approaches in many, many contexts, okay? Even in our school, sometimes we report indicators like this, okay? So be careful when reading this kind of bar charts because maybe you are being manipulated to have a different perspective or a different perception of what really happened, okay? So be very critical when reading any kind of chart. Here we have an example. On the left, it starts in 0. On the right, the same data set starts in, I don't know, 28K or something like that. So you can see that the visual impact is very, very different, okay? Both are correct, okay? But what you want to convey as a message? Do you want to show some kind of stability? Maybe you'll select the left, right? If you want to show changes, maybe you show the right one, okay? So it really depends on the questions you want to answer with your data set. That's why it's important for your final project to write those questions down and then try to figure out the best option for answering those questions, okay? Or maybe instead of representing absolute values, you could represent changes, okay? Okay, take the bar charts. Take bar charts. So here you have one quantitative value and two categorical key attributes. Okay, so let's see an example. So one quantitative value on the y-axis, okay, like a normal bar chart, but on the x-axis you have two qualitative attributes, okay? One for each bar, okay? And then an additional one that allows us to distinguish several portions of the bar with different values, okay? So this can be interesting, but my suggestion is that if you use stacked bar charts, try to add labels with the values for each portion, okay? If possible. Sometimes it's not possible because then the labels become illegible, okay? Not legible, okay? So, because we are not so good at comparing sizes of non-aligned bars, okay? For instance, the red on this bar is very similar to the red on this one in terms of size, but we are not sure which one is the longest one, okay? So this can be a problem, but sometimes this is useful, or maybe you can create an application in which the user can click on each portion of the bar to figure out what's the exact value of that portion, okay? Going back to the Titanic example, we have a stacked bar chart on the left showing the passengers that died and survived in blue, died in red, according to the class ticket, okay? So maybe not a good idea to go in third class, okay? So we have more people dying there, of course. They also have more people in the third class than in the first class, okay? So this is absolute numbers, okay? On the right, we have a proportion, okay? But this confirms proportional number of people dying in third class is also the highest. It could not be, but this is, okay? So first class, it's where most of the people survive in terms of proportion. Third class is the worst. So we could use stacked Irish charts with absolute values or with proportional values. On the right, you need to be aware that you are losing the information about the absolute values that you could deliver also using labels, for instance. Okay? Any question? Okay, so continuing. Okay, here we have an example showing the same data set. On the left using pie chart, or on the right using stacked bar charts. Okay, it's the same data. Which one do you prefer? Okay, remember, we are not good at comparing angles Remember the ranking of effectiveness? You have the tilde in the middle of the table, not on the top. Okay, so we always prefer compare lengths than comparing angles. So we should always give priority to bar charts compared to pie charts. Okay, but here in this case, we can see the correspondence. Now it's up to you to decide which one you prefer. As I mentioned before, using data visualization principles, accuracy is much better for our visual perception by using bar charts. Okay, so it doesn't mean you cannot use pie charts. You can use pie charts, but you need to be aware of these things. Okay. Okay, stacked Irish charts. Or 100% stacked Irish charts on the right. Okay, so let's start with the left. So in the left, we have one quantitative attribute, and on the x-axis, we have an ordered attribute. Can be, for instance, months, or quarters, or weeks, and this could be, for instance, market share or market sales for each type of product A, B, and C. Okay, so this is not easy to read. Okay, for instance, I think the only part that is easy to read is the first pink product. We can see the number on the y-axis and its evolution over time, for instance, number of sales over time. Okay. But for the second product, because it doesn't start in zero, okay, we need to calculate the difference between the maximum and the minimum value, so we understand how much corresponds over time in terms of sales. Okay, so I think we should avoid this use of charts. Of course, it depends on the objective, but typically it's not so easy to interpret. And that's even more difficult when using a 100% stacked Irish chart. Basically, we are converting the chart on the right to a proportion. So instead of using absolute values, for instance, number of sales, we are using proportion of sales. Okay? So this is even more complicated. So this is the correspondence between a stacked area and the line graph. Okay, so which one do you think it's easier to interpret? The one on the left or the one on the right? Okay, this is exactly the same data set. Okay, I would say it's definitely the line chart. Okay, for instance, the blue it's easy to figure out because it's the one on the bottom, but the green, yeah, I know it's the side, it's pretty much similar from beginning to the end, that's why it's a stable line. But the orange line, it had a big market share in the beginning, and then in the end it's zero, so it goes from the highest value to the lowest value. Okay? I think it's much easier to understand the chart on the right. Okay, you might disagree, but okay. String graphs. Okay, string graphs. I have one quantitative attribute, if we count, and one ordered attribute, can be time, plus one categorical key attribute. In this case, can be the artist. Okay, we have here this example. Sorry, you cannot see the labels from the book. So the labels are rock bands, music bands, and this is a representation over time. Okay, so color encodes the music bands, and then the size of the area represents its success. Okay, so if it's a large area, it means lots of records were sold or listened to. And we can see over time what's the progression. Okay, so we can do this kind of representation. Here, this is also something that is more interesting in aesthetical aspects, so it's not very accurate. Sometimes we see these kind of charts in which the aesthetics are privileged over the function or over the accuracy. That really depends also on your objective. Sometimes aesthetics are more important, but I would say that in our line of business here at Nova MS, we are more interested in accurate and function effectiveness of our products than more in aesthetics. Okay, but aesthetics might be important, especially if you are publishing in a news journal or in a poster that you want to attract the attention of people to look at it. Okay, but for doing this kind of aesthetical representations, you also need to be a person with knowledge about design, okay, which is not my case, maybe not your case either, or for most of you, okay. So I'm terrible with design, okay. But sometimes for developing good products for general public, we cannot just trust in simple applications or simple charts. We need to come up also with a team in which a web designer is also involved, okay. So it really depends on your objective. For this course, I will not be judging about the quality of the design, but more about the function and the effectiveness and the accuracy of the truthfulness to the data set you are working with. Okay. Okay, other examples: stacked bar charts, stacked area charts, and line charts. Which one do you prefer? I definitely prefer the line chart, okay? Because the first option, the stacked bar charts, it's very difficult to compare the sizes of similar portions of different bars, okay? They are not aligned to zero. On the line chart, they are all aligned to zero. It's very easy to compare the values of each line against the other one, okay? Okay, so we have here a good example of a stacked area chart. I think in this case it works well. We only have 4 quarters, okay? We have sales per region. Each type of blue represents a region. And we have actually the value of each proportion. So if you sum the line altogether, this is 100%, okay? Not the column, the line, okay? So I think this is a good option for this specific case. Doesn't mean it's for your data set, okay? That's why we should understand what are the options available so we can actually come up with the best chart for our data, okay? This is an interesting stacked area chart. We also need to know how to call names to these different types of charts. So we try to understand and know them, because then if you want to communicate with anybody, we should be knowledgeable about what kind of charts we are using, okay? This is a stacked area 100% chart, okay, showing the evolution of professions in America since 1850 to 2000, okay? So we can see that in the beginning, there were mostly farmers. Then farmers over time decreased a lot because there was mechanization of agriculture. So it has become a work done by machines and not by people, okay? And we can also see other types of profession. For instance, secretary in the 70s were very important. Now they are being less important, etc., etc. Okay, so this can be a good option to show a big quantity of data and its evolution over time. Okay. Okay. So dot charts. Dot charts are representing using points as marks. Okay, we have one quantitative attribute and one qualitative or ordered attribute. Okay, so let's see an example. So we have points as marks. This is not the scattered plot. Okay, for the computer, years are quantitative data, but these are ordered attributes. Okay, years are ordered attributes. So this is not a quantity. Okay, so we are representing this against weights of cats in this case. So this is a quantitative attribute. So don't call this a scatter plot, please. This is a dot chart. And we can connect dot charts using lines, so they become line charts. Okay. Another example of line charts. One very common mistake is connecting ordered attributes or discrete attributes using lines. Okay, so we should never do this. Okay, you cannot connect items which are not continuous. Okay, so don't do this kind of nonsense, which is to create a line chart to connect two attributes which are categories and not ordered attributes. Okay. The example on the top is wrong. The example on the bottom is okay. Okay, baseline problem again. As I mentioned before, our options in data visualization always have an impact on the visualization perception. Okay, so it really depends on what you want to do. Of course, it should be truthful to the data set, so you show the truth. Okay, so let's not try to be manipulators or trying to deceive people. It's very easy to do that. Okay, it's easier than you think. For instance, we have these three options for representing some attribute, in this case, quantity of dollars over time from January to October. It could be sales, for instance. Okay, we could represent with the first chart, the second, or the third. So all of these represent or have an impact on the visual perception. Okay, so maybe if you are interested in showing some stability, I would show the first chart. If I want to see some activity changes, maybe I'll show the second chart. If I want to show a drastic or a dramatic decrease, maybe I will show the third. All of them are correct, okay? But it's up to us to be in charge of how we want to deliver the message. What story do you want to tell behind the data you have? Okay, so we have an important responsibility. Okay. Another way of controlling the appearance of the chart would be to contract or expand the size of the x-axis. Okay, so this is exactly the same data set. And if I use a more detailed x-axis or a more expanded x-axis, I will be telling a different visual story, right? Maybe the first chart, so it shows some change. In the second chart, you show a dramatic drop, okay? But if you want to show stability, maybe I'll choose the third chart. So which story do you want to tell, okay? We can control this. This is all correct. None of these charts is wrong, but you need to be aware that will be causing an impression, a different impression, depending on the chart or on the way you are going to control the size of the axis. Okay, be very careful with this. Try to be truthful. You don't want to go to your CEO charts that not correspond to the truthful meaning of the data set. Okay, so here's another example of changing the detail information in the axis. Okay, can be more abrupt or more stable depending on the side of the axis. Okay, you also have here the possibility of plotting linear scale, which is the most common feature, or you can also choose to use a logarithmic scale. Okay. On the top, we have the representation of Apple stock prices in the 90s. Okay. In the beginning, the value was not so big. I wish I had bought a lot of them here. But suddenly, when the stock prices start to increase a lot, we can see the changes in the linear scale. Okay. But if you use linear scale, you'll be missing a lot of changes when the prices were low. Okay. For these cases, maybe, or it's much better to use logarithmic scale that enables us to depict the changes more correctly. So if you are a stock market investor, you are more interested in the changes, okay? That's where you make money. So even if the price is low, so maybe it's better to use this kind of approaches using a logarithmic scale. So if you work with stock market data, if you go to those usual websites, you are able probably to change between logarithmic and linear scale. Okay, so take a look at any website with stock market prices or crypto, and I'm sure you will be able to have these options too. Okay, so if you want to learn more about when you should use logarithmic scales or linear scales, take a look at this article which was published on Forbes. Maybe you want to use this possibility in your application for the final project. Okay, so try to justify why are you doing it. Don't just put there logarithmic scale. This is not something that the average person understands. What is it? Okay, so only use logarithmic scale if it is for a specialized audience. Okay. Okay, errors to avoid. For instance, sometimes we can see this kind of examples, dual axis scales, okay, in which we have, for this case, for the same unit in dollars, on the left, this size corresponds to $500,000. On the right, this size corresponds only to $25,000. So this is a very wrong visual perception. It looks like the values are comparable, which they are, but we should use the same scale for representing the same units. Okay. So on the left, it's the correct representation. On the right, it's the wrong representation. Okay. A few more examples, and you can take a look at them. Okay. So heat maps. Probably have seen heat maps before. Okay. To work with heat maps, we need to have 2 qualitative attributes and 1 quantitative attribute. This is very important. Please, when looking at your data set, identify, also describe if they are quantitative or qualitative, because this will limit your possibilities on the type of charts you can use, okay? If you are using Tableau, for instance, when you drop or when you upload the table there, software immediately recognizes the field types, and according to those, he or she suggests you what type of charts you can create from those type of data sets, from those type of data attributes, okay? So this is also an interesting challenge for you. So whenever you look at the charts, try to do some reverse engineering to imagine what kind of attributes and values you need to create one chart of that kind, okay? So this is a challenge. Please always do this kind of reverse engineering to see if you can create these charts for your data set also, okay? We have here an example. We have the qualitative attributes, the X and Y axis, okay? Then we are representing a quantitative attribute that reflects the number of deals in this case. Color plays a very important role here. So color needs to make sense. If the color is a tutti frutti color here, it's doesn't mean anything, okay? But because it's a heat map, it should represent heat for some kind of phenomenon, can be number of sales, number of deals, whatever, and should be described in the legend. What's the meaning of the colors, okay? If this would be a tutti frutti color scheme, it would not make any sense. So it would not be a heat map, I would say, okay? So you could use this kind of green to red, or light blue to dark blue, or light red to dark red, things like of that nature. So, okay. So this is more for scientific visualization. You can also have cluster heat maps. Okay, this is more complicated, but it's possible, especially if you are working in data classification procedures. Okay. Okay, scatter plot matrices. Probably some of you have heard about this concept before. So scatter plots, we already know what it is, right? So we have at least two quantitative attributes. In this case, we create a matrix out of that because we have dozens of attributes like this, okay? For instance, on the diagonal, you have the names of the variables, and you can plot each variable against the other one to see if there is a relationship between them. They are correlated or not, okay? This is very helpful for working, for instance, in regression models to see which are the variables that are correlated between each other. Maybe you can then remove one of those variables because they are pretty much correlated. Maybe we don't need them for our regression analysis, okay? So for doing this, you can find multiple libraries in Python or in R for creating scatter plot matrices, okay? Okay, we have also the possibility of creating 3D grids, okay, in which you have a volume to our cells or to our pixels according to some attribute value. For instance, maybe some of you have heard about pixels. You know, pixel means picture multiplied by element, pixel. Okay. Here we have voxels, so we have volumes multiplied by elements. So these are 3D representations of pixels. Okay. If you use GIS, you know what I'm talking about. We have here a problem, which is the 3D perspective, okay? We have this occlusion effect, we just see one perspective of the data, so we might be hiding or missing a very important feature of the data. Okay, depends on the perspective. Okay, we can also have multiple keys. For instance, like the case we have here, we have multiple variables, quantitative variables grouped by state in this case. Okay, so we can represent this kind of recursive subdivision in which we have multiple keys. If you want to do scatter plots, if you are using R, for instance, I didn't put here an example for Python, but for instance, this website, at least when I consulted it, it had code examples for 98 basic scatter plot matrices. So you can imagine, so my objective here is not to show you the 98 basic scatter plot matrices. My objective is here to show you what is a scatter plot matrix, okay? But I want you to understand that there are multiple variations for each type of these visualization idioms, okay? So it's up to you to decide which one are the best fit for your data set to answer the questions you have raised for your data set. Also, this also allows me to talk a little bit about differences between using coding like Python or R or ready-to-use applications. So if you are using Tableau or Power BI, you are very much more limited to the options made available in the software for you to create data visualization product, okay? If you are using coding, you are much more free and flexible on your selection, okay? I know it's also possible to connect R to Power BI and things like that, but we are not going to cover this. But you are free to explore the level of complexity you want to add to your data visualization product, okay? Okay. Okay, now regarding the spatial axis orientation, this can be rectilinear, it can be parallel or radial, okay? So we have here an example for the same data set. We have a table with several disciplines, and here can be maybe the grade of someone, or each item can be a student, for instance, each line is a student. I could represent the scatter plot matrix to find correlations between the disciplines. For instance, math against math, it's a perfect correlation, okay? But maybe the students, how do the students in math relate to dance? We can see if there is a correlation or not. So we can try to figure out what's the relationship between the several disciplines for our data set, okay? Or I can use this using a normal rectilinear representation when we are used to it, okay? The axis orientation X and Y. Or I could also use parallel coordinates, okay? I think I already showed the example for this one, okay? We have here several dimensions of the table, several attributes, and for each one, I represent my items according to the values of each dimension. So each item has different grades for different disciplines, okay? So parallel coordinates can represent hundreds of items, but this can become very, very difficult to see unless you provide the user the possibility of creating some selection criteria using the dimensions, okay? For instance, let's say you want to select a car with 3 cylinders, okay? So you could drag and drop, I think this is still working. You can drag and drop a slider for each axis, and in the end, you only see the items that correspond to the criteria you have used, okay? So this is one way of giving the user an open exploration tool for deciding, for instance, which is the car that fits the needs for that particular person. Okay, this is really outdated. Now it's everything electric, right? Okay, another spatial axis orientation example is radial. Okay, but if you remember the effectiveness ranking, humans are good at comparing lengths, but they are very bad or not so good at comparing angles. Okay, if you check the ranking of effectiveness, tilt is not a very effective visual channel, so better to use lens, which is on the top of that ranking. Okay, we have here an example. Pie charts, which uses angles, bar charts, which uses lines, or we have here a polar area chart, okay, in which we use a radial orientation as well as in the pie chart, okay? But pie charts are already difficult because we are not good comparing the sizes of very similar slices, right? But if you go to the polar chart, this is even worse because it's not just the angle, but it's also the size of each slice. So we are even in more difficulties to compare the real sizes of each slice against all the others. Okay, so here the best option is clearly the bar chart. Okay, then the pie chart, and only then the polar chart. Okay. Sometimes it's used, so we need to know that they exist. There is this famous representation of the British Army depicting mortality from 1854 to 1855. So starting on the top, we can see in green the casualties outside battle, and then the casualties inside battle. And we can read this throughout time and see the progression. But it's very difficult to compare the size of the areas of each slide. Okay, so it's good to tell a good cyclic story because it's cyclic data we're talking here about, but it's not so easy to be accurate in the values that are depicted in this representation. Okay. Okay, here you have a very interesting example. This is a very well-known chart. On the left, we have the original representing the Arab Spring, in which we have countries with different colors, and we have a cyclic representation, so it represents time. So and we have the date of the events starting and ending in each country. Okay, and in the bottom we have the legend with colors, different colors, and their meaning, which is about the number of victims. Okay, so we can see which was the event that took longer, the one that provoked more casualties or victims, and where did it happen? Okay, in which country did it happen? On the right, we have an improved version. I mean, improved in terms of accuracy. You can see much better real values, and also in terms of effectiveness, because we are much more fast to read the values on the right than the values on the left. So I'd say that the chart on the left, maybe it depends on your taste, it's more aesthetically interesting and challenging in terms of difficulty to create something like that. Maybe it's more interesting for general public to show a more sophisticated and beautiful chart. But on the right, we are privileging function and effectiveness and accuracy over aesthetics. Okay, so you are here in data science course. I think you go for the second option, the one on the right. If you want to go for the first option, you need to also have some skills related to design, okay? Not just data science, okay? So also selection of colors, all that goes with design capabilities, I think. And not all of us have those skills, okay? At least I don't have. I cannot talk for yourself, but maybe most of you also don't have any kind of design skills, okay? So whenever we are producing this kind of products, if it's for impressive displays, I think maybe you should have also a web designer in your team, so you can come up with some more interesting and appealing visualizations, okay? But for data science, I would say that the one on the right is the one that fits the objectives of this course, and I think also the objectives of the master you are enrolled in. Okay. So pie charts versus bar charts. So we always prefer bar charts. We are better with lengths than with angles. Okay, there's no question about it. We can also use some donut charts, which are here represented. This is a variation of pie charts. In this case, it's correctly done because you can be very accurate comparing the quantities on the left with the quantities on the right, because you have a label for that, okay? So in this case, there is no room for misinterpretation or for comparing wrongly the sizes of the portions of the donuts, okay? Talking about donuts, it's almost noon. I'm just kidding. Okay, so then about spatial layout density, we can use dense representation, especially when we are working with very big quantities of data. This is a more specialized type of audience, I would say even scientific audience, when we see this kind of representations. But we can also use some space filling option, like the tree map on the right, in which we use the whole available space to compare the values of the variables according to some qualitative attributes. So these tree maps are interesting, especially if you don't have too many attributes, because at a certain moment it's very difficult to see what's there when you have too many attributes, but also if we are using different sizes of rectangles for us, because they are on the line, it's very difficult to compare the sizes of the rectangles. Okay, maybe you could also add here the real percentage for each rectangle, but if you have too many rectangles, you cannot do that because it will become too much data in the same figure. Okay. Yeah, that's what I had to tell you for this part here. What was the point of this class is, okay, you have a data set, hopefully. If you don't have a data set yet, think about getting one. You have less than 1 month to finish your project. This is a trimester course, don't forget about that. 9th of April is the deadline. Then you'll have the presentations that are going to be defined per group, so each group will have a specific date and hour. But yeah, try to get the data set as soon as possible, because whenever you have the data set, then you can start thinking about what questions you want to ask to the data set. Okay, I want to ask these 3, 4, 5 questions, and for each question, you are going to have to find one visual idiom to do that representation, which can be a scatter plot, it can be a multidimensional scatter plot, it can be heat map, etc., etc., etc. So we need to be aware of the possibilities we have for our data set to answer the questions we have raised. Okay, that's the objective of the course. Okay, the idea is not to produce 20 charts from a data set. Okay, the idea is to produce an answer to the questions we have put in the beginning, so we can communicate effectively then the answer to those questions with the data visualization product we have developed. Okay, so some of you will be using Python and Plotly and Dash. Others maybe are more interested in Tableau. Okay, but the visualization perspective, it's the same. Okay, either you present it in Tableau or Python. For me, what's more important is the story you are going to tell and how we are going to tell it with the charts you have selected. Okay. Of course, then there is also the level of the complexity, but the level of complexity will try to be fair in that judgment, be it Professor Bloom or Professor Mafalda. Of course, you can use ready-to-go charts in Tableau, but I know that it is also possible to create more complicated things there. Okay, so it can be a basic Tableau presentation or it can be an advanced Tableau representation. Okay, and the same goes for Python. We are aware of what can be done using that tool, and we also know what's a more advanced use of that tool or a more basic use of that tool. But in the end, don't forget the visualization perspective. I was just talking about the level of complexity. Of course, we'll try to give more points to more complex solutions, but never losing from sight the objective, which is to deliver the message in a very effective way. Okay. Okay. So next class, I will talk about spatial data. Okay, so let me see. So next class, I'll talk about probably spatial data, which I didn't cover today, and network data. Okay, so I'm going to talk about chapter 5, and so it should be here. Yeah, graphs, networks and trees, and spatial data. Okay, so then I'll be back to the evaluation. Actually, thinking better, this evaluation goes much better in the end of the theoretical component and here in the middle. Okay, but you can start already reading, you know, the chapters, and all these chapters here are good for the quiz. Okay, so don't forget we have the quiz during the class. So depending on the group you are, 27 or 28 March. Then we have the project presentation after 9 of April. 9 of April is the deadline. This is the first phase, test or quiz and project presentation. Okay. Then if you fail or if you are not happy with the grades or if you don't deliver the work, you have the final exam, the second phase only. Okay. There is no first phase exam. It's only the second phase exam. Second phase exam can be 100% if you didn't deliver the project, which is not recommended, or it can be 50% for the project and 50% for the exam. Okay. Any questions? Are you still there? Okay, next class will be in normal schedule, finally, okay, unless there was some unpredictable event, which is not the case. So we are...
I have a question, sir.
Yes.
Which one do you recommend? Do the project or take the exam? What's your favorite?
I prefer you to do the project always. okay?
Okay.
So, because it is a practical class, and of course, it can be very knowledgeable about the theory and the principles and get a good grade like that also. But you are here also to learn how to do things, right? So hands-on, I think it's a very important component of your skills. So I would not miss that. Okay, so I would definitely recommend you to do the project. Okay.
Okay, cool. Thank you.
Also, so next class will be next week already. Actually, Monday, right? Monday and Tuesday, so depending on your group. So for this group, I think it's Tuesday. So see you there. I'll be here in normal classroom. So this session will be broadcasted also, but will not be recorded. So this is not compensation class. So usually the sessions are not recorded unless for this reason we may share to miss the class due to unexpected reasons. But so these two sessions that were on Saturday, they will be available online. All the others, no. Okay. So my final advice is, okay, you have less than 1 month for the project. So it's about time to start working if you still haven't done that yet. Okay.
Professor,
Yeah.
may I ask a question about the project? You said about setting some questions, and we should answer multiple questions based on the data visualization, right?
Yes. Yes.
Okay. Okay.
Yeah, that's a strategy. You can think about this like developing a software product. Okay. You need to do a list of prerequisites in the beginning. Okay. So in this
Okay,
case,
thank
I
you.
suggest you questions for which you are going to develop visualization products that should answer those questions. Okay. So in the end, you can match the product with those prerequisites to see if you are okay or not with what you wanted to achieve. Okay. Otherwise, you'll come up with, I don't know, 20 charts, and we don't value that. We don't want that. Okay. We don't want to see 20 different charts, which are there is no clear reason for them to exist. Okay.
Yes, understood. Thank you.
Good.
I have another small question.
Yes.
If I do a dashboard instead of graphs one by one, would you accept it? Would it be,
It
I
can
mean, how do you
be-
take it?
It can be a single chart if you want. For instance, I've shown you in the previous classes some data visualization products from New York Times, for instance, that they were excellent, and they were just one visualization, one product. But of course, you can do a composition of visualizations in a dashboard, which are interconnected or not. That's up to you. But you can use a dashboard, or if you want, you can even use a story. Okay, if you use software like Tableau, you have this possibility of creating individual charts over a sheet. Okay, or you can create multiple sheets altogether in a dashboard, including maps if you want. Or you can create a story, which is a sequence in which the user can go back and forward of dashboards. Okay, so of dashboards or individual visualizations as charts. So it's up to you how you want to present your final product. So it's really up to you to decide what you want to, how you want to present it. Okay. So
Okay. And
can you-
also during the presentation, if I create a dashboard in Tableau, let's say, for example, do we have the facility to use it in our presentation to explain?
Yeah, the presentation, you'll be sharing the report with me and the other professors. We'll read it, so we need to be here ready for a discussion. Also, typically you will open your data visualization product, you'll be ready and prepared to explain development options. How did you do this or that? Be prepared also to show the contents of the data set, the codes you have used for Python, or the project we have used to create the visualization in Tableau. So you need to be ready to present anything. You don't need to present a PowerPoint, okay? So you just need to be here and show here or online and be ready to explain the development options you have taken, okay?
Right, okay, thank you.
Sorry, just one question. Can the test be done fully online?
Yeah, because this, for the first phase is a quiz, you can do it online. But you need to have camera on, okay? And yeah, it will be not work a big part of the grade as in the second phase. But it can be fully online, or you can be here with me in the classroom, as long as you bring your computer. Okay.
Okay, thank you. And how is the date determined? Sorry, by the group? You were saying.
I didn't get your question.
How is the date for the test determined?
Oh, depending on your group. Okay, so you should come to the group in which you are enrolled. Okay.
Okay, the practical class.
And theoretical. So we have 2 sessions of theoretical classes. You belong. No, sorry, you have 3. Yeah. So you go to the group of the theoretical class. Okay.
Oh, okay. Thank you. I got it. Thank you.
Okay, good. So ready for the weekend or not really? So be careful because you only have 1 month, less than 1 month. Okay, so if you don't have your data set by now, you should start to be worried. There's a lot of data out there. Okay, so I would recommend World Bank, for instance, or IMF, or census data from your National Statistical Office. It's much easier to tell stories about those socioeconomic indicators. So why not use it? Or you can use some more technically oriented data sets like the ones you see on Kaggle from industries. So, but of course, there is always this work of reprocessing the data, right? So you need to spend some time reprocessing the data. Maybe some of the data you're going to use is to be reported with maps. Why not? You can create a choropleth map showing an indicator in your country, or it depends on what you want to answer with your data set. Okay, so start thinking about that. This is group project, so I really believe that writing down the questions, 3, 4, 5 questions, the questions you want to ask your data set are important. Okay, then for each question, figure out the best option in terms of visualization to answer that question. So try to help the reader to see the answer to that question. Okay, so you can use a title, you can use some text, you can use some good colors, some other strategies, pre-attentive features. Are you going to use pre-attentive features to help the reader to automatically answer that question without spending too much time? Okay, if you give the possibility of the user to get lost in filters, possibilities of navigation, etc., maybe in the end is not going, or he or she is not going to be able to answer that question. So you will not be delivering a message, you are delivering an open like exploration tool that can be well used or not well used. Okay, but here we are in charge. Let's try to be in charge of the message we want to deliver. So let's try to build an application in which we show already what he or she should interpret. Okay, so we want to manipulate in the good sense, the message that is going to be delivered in a very effective way. So we are going to help the reader to go into that direction, okay? Okay, so I will think if you don't have more questions, I will stop the recording now. Then you can consult the recording and see you Tuesday for the next class, either online or in presence. Okay, so have a nice weekend.
Thank you.